The gist of this API is that you get a token on how much you can trust the device the application is contacting your backend. This is useful when you have a backend system with some valuable information there. Can be a game, for example, if you want to have coins in your game and having transaction on the backend, you want to trust that this is coming from a real device, not a Python script, and is not coming from someone that is trying to cheat on the game. Hi everybody, I'm Pietro Maggi. I'm going to talk about trust today. To introduce myself very quickly, I've been in Google 5 years, in DevRel, and now in Android Enterprise. The reason to talk about this API will come clear understanding what is Android Enterprise. Android Enterprise is not a different version of Android. It's a way to use Android devices for work. So there are components like making it more secure, so having the possibility to lock down some feature, the possibility to control and manage this feature, having something like the work profile that you can switch off and improve your life quality during the weekends with no notification coming from your job. But the talk today is not about Android Enterprise, it's about the Play Integrity API. Play Integrity API, it's a devolution on SafetyNet Attestation. Includes some of the functionality of SafetyNet Attestation and much more. And the reason why I'm interested in this API is that there are two main use cases for this API. Games and enterprise. So I like games, I work in enterprise, so I say, why not? Why don't talk about this API? So, Play Integrity API. The Play Integrity API, the gist of this API is that you get a token on how much you can trust the device the application is contacting your backend it's on, how much you can trust the version of the application that is contacting your backend, and how much you can trust the user account that is contacting your backend. So this is the link to the documentation on DAC on developerandroid.com. The basic idea is that this is useful when you have a backend system with some valuable information there. Can be a game, for example, if you want to have coins in your game and having transaction on the backend, you want to trust that this is coming from a real device, not a Python script, and is not coming from someone that is trying to cheat on the game. So to make the game safe. So it's really about verify the authenticity and the integrity of the request that this backend is receiving. Okay, is this, just to make it clear, the Play Integrity API is not the only anti-abuse strategy that you need to put in place. It's an important part of it. We are going to see which kind of information it can provide, but it's not the only one. It's also important to work on the security practice for your application, so to keep the data safe for the user. And this is very important to gain and maintain the trust of the user. It's very difficult to get the trust of the user, and it's very easy to lose it. So this is important why, this is why it's important to have a good security hygiene in your application and your system. Okay, why you may need an attestation verdict. Attestation verdict, we are going to see what is it, an attestation verdict. But the idea is that the user is doing something, contacting the server, and the server wants to check if this is something that needs to be, can be trusted. So a user is asking, for example, to donate some coins to another user. Your application requests a Play Integrity API assessment. Play returns a verdict about the device, the application, and the account. And everybody is happy. Your backend can decide if this can move forward, so I do the transaction, or if there is some doubt on the veridicity and the integrity of this request, and maybe do a challenge for the user. The verdict. There are two ways to get a attestation, a token verdict. The classic way, the classic request, if you are familiar with SafetyNet Attestation, this is very similar to the classic request. It's starting from the backend, going to the device asks the API, the application that contacts the backend contacts Play sends back the information to the backend, and then the backend tells the result to the application. So yes, it's many hops, and it's taking a few seconds. So you want to use a classic request if, for example, you are doing a transaction on a financial application, your bank application, before accepting maybe some transaction, want to do something as expensive to spend a couple of additional seconds. It's not something that you want to do on the application 100 times, 1,000 times a day, because it's going to kill the user experience. And this has always been a problem with SafetyNet Attestation. So if you wanted to have a light way, a way with a lower latency to get an idea of how trustable is your this request, there was no way in SafetyNet Attestation. Play Integrity API has a new way to request a verdict, the standard request. In this case, it's a low latency. We split the job in two places. You have a setup time where you can set up a particular object that you can use then when you use the application to request a verdict on a particular transaction. So this is the classic API request. You see we have 4 actors: the Play server, the application server, your backend, the application on the mobile device, and the Integrity API. The basic idea is that you want to prevent to have a relay attack, so the backend starts with generating a random number, a nonce, and this is used during the call to ask a verdict from the application to the Play API on the device, and is sending back a token. The token also includes the information about the nonce. So the backend server can check that this is the same request. It's not another request that is replayed to the backend system. This information is sent to the Play server, is checking information about the build of the operating system, the device, the user account, the application information, and it's providing a result to the backend. And then the backend can decide what to do. Is this something that I want to proceed, I want to ask more information, or I want to deny? Standard API request, it's same actors, different story. This is a 2-act story where you have a setup where you generate this standard token provider object, and then you can use the standard token provider to validate an hash and build, instead of having a nonce that you use over and over again, it will not be safe. You generate on the client a request hash of the hashing the information that are part of your request. There is some limits on the size of this hash that we are going to see, but the basic idea is that this can be used to validate the request and the hash are containing the same information. And then the rest of the steps are similar. The token is going to the application server, decrypted, verified, so it's checking that this request hash contains the right information, and then the token payload is coming to the backend system, and there is a decision again. You can use both kind of requests in your application. If there is something very valuable, you probably want to use a the classic request. It's more expensive, but can guarantee a higher level of security. But for day-to-day, if you need to validate many operations that are not so valuable, that are not so expensive, you can probably use the standard request. The integrity verdicts that you are going to get from this application is JSON with 4 different fields. You have the request detail. This is different depending if you are doing a classic or a standard request. For the classic, you get the information about the nonce. For the standard, you get the request hash. Then you have the app integrity, and these are the application information. You get the package name, the hash of the application, and so on. So it's information regarding the application running on the device. Third element is the device integrity. So you get information about the integrity. We are going to see that there are different levels of trust for the device. You can have different level of trust. The default is to just give you 2 levels. That is, you can trust the device or nothing. And the last is the account information. How much you can trust this account. So there is an app licensing verdict. The idea that is this, if this is an application with a license, if the user has the license. So, and these are the 4 information you get in the verdict. The device integrity, you see this is, I wanted to focus on the device integrity. The default is the mid-device integrity that you can get if you can trust the device. If the device cannot be trusted, you get a blank instead of having a value. You can enable in the Play console to have additional information. You can have a basic integrity or a strong integrity. Basic integrity is practically, this is a real device, but maybe is not certified by the producer, or is a custom ROM, or the bootloader is unlocked. But it depends. Maybe that it's enough for you that it's not a Python script hitting your backend system. So maybe that for this particular operation is good enough. The strong integrity, instead, we are certifying that there is an hardware-backed chain of trust on the device. So there is a bootloader, it's locked, the operating system has been certified by Google, so it's signed, all the correct information are there. So there is a strong integrity on the device. Depending on which kind of operation you are doing at this moment on the backend, you can decide that a basic integrity is enough, or you can decide that you want to have strong integrity. Okay, how do we set up this API to use? Because there are different pieces. It's not an API that you integrate in your application and you're good to go. There is an integration on the server side. There is a setup in Play. So starting from the idea, which are the elements that you need? You need to integrate the application on the Play console. So you need to enable the Play Integrity API on the Play console. You need to integrate in the backend. So the backend can be whatever you want. It can run on GCP. We have a code lab that shows how to have a backend running on GCP. But whatever you like. There is a GCP component because you need to have a GCP project to use this. But the backend by itself can be whatever you want. And then there is the mobile part. Mobile part, we have a support for Java and Kotlin, support for native, so in C and C++, and support for Unity. Because as I said, a huge use case for this is game. Starting from Play, there is an app integrity section inside the Play console where you can enable the integration. You can also enable the additional device integrity signal. I don't see why not, put in this way. And you can set up also test account because how do you test the integration? You can set up that for a particular account, you want to get always that it's failing, the verdict is negative. Or for another user account, you want to get always strong integrity, and so on. You can test all the results using different accounts without having to root a device just to get that doesn't meet the basic integrity. Because there are calls involved on the server side, there are quota. The default quota is 10,000 requests a day. It's good for starting and doing the integration and so on, but if you want to go in production, it's probably a good idea to request a quota increase. The quota increase takes a few days. I don't know how many, depends. If you're asking probably around some holidays, it's taking a few more days because it's going to be manually reviewed. So if you are planning to go in production, it's probably a good idea to plan in advance to request a quota increase. Just saying. For mobile, Java and Kotlin, there is a surprise, a library that you can integrate. The current version is version 1.2. It's important that you use at least version 1.1. That is the version that started to introduce the standard request. By the way, standard request is in beta. But we know that beta is good enough for production, so. And it's even safer because nobody kills project in beta. So just saying, it's not going to be deprecated. Okay, so for native, there is the PlayCore native SDK, and for Unity, there is the Google Play Integrity plugin for Unity. 1.1 or higher, you get the feature for classic and standard request. What is a standard request? How you do a standard request? You have a warm-up, so we say it's a 2-act scenario that you do in 3 steps. You warm up, and then you always do a request and a decrypt and verify. So this is, you do once, and for each request that you want to validate, you have these 2 actions. How do you do the setup? We want to receive this, the token provider. So you start to request the token provider. You see that we have a cloud project number that you need to pass as a parameter. And you pass the parameter then to be in this builder. And if it's successful, you get the token provider. Otherwise, you have an error. The request of the verdict, this is on demand. This is what you do every time that you want to verify a request. So in this case, you use the integrity token provider. You have a request hash. This is where you are hashing the information that you want to protect. Some of them, the most important. This is what is coming to the server, and the server is going to use the hash to check that the request is receiving is about this hash. You see that few things regarding the hashing. Its maximum at this moment is 500 bytes. So if you have many information, you put there the most important, the most critical. And probably you don't want to put there plain data, because this is going to be available on the network in some way or another. So, and for the verdict, you see that you use the integrity token provider to call the request. So I have my hash, and I create a new request, and on success, I send to the server the response token. Otherwise, I have an error. Again, in this case, the upside and the server side digest, they need to match. Otherwise, the request is not trustworthy. This is the way to, the hash is practically what you use to avoid a reply attack in this case. And this is why it's important to put the most important information inside the hash. This is from Play. It's when you do the integration, you can start to see some information. There is a dashboard that tells to you, okay, these are the total requests, meets device integrity, Play, recognize, and so on. From there, you can get an assess of how it's working in the field. But probably makes sense to test and plan for errors, because, you know, sometimes it happens. For testing, we have 3 different ways to do the testing. On the device, you can check if you have a problematic device and you don't know why it's not working. You can, from Play, you can ask to generate a device integrity result. From Play, as I said before, you can set up email account and specify, okay, for this particular email, for PFM test 1, I want to always get a meet integrity. For PFM 2 at gmail.com, I want to get meet strong attestation and so on, strong integrity and so on. And the last one, it's the retry, in the sense that some of this error that you are going to get from the server are intermittent. So we are working to provide more guidance on some of this error. But you are going to see that there is one error returned by the API that is an intermittent error. So in that case, the guidelines is to retry with an incremental backoff. So how to test a single device? I don't know if you know, but the Play application on the device has a developer mode. And you enable the developer mode, tapping on the Play version 6 times. And then you are in the developer menu, you get the option to, for example, enabling app sharing, and also now in the latest version to generate a Play integrity result, a Play integrity verdict. So you get the integrity verdict. In this case, it meets basic integrity. The device details, Panther is pixel 7, and a test ID that you can use then in the logs if you need. You can, as I said, set up emails. One thing is that you can check if the verdict you are receiving is a test, because in the verdict there is this additional information in the JSON. This testing details is now true. In the error codes, there are 20 maybe error codes. You are going to get a numeric value. There are different errors for the classic request than from the standard request. To know what is the error that you are receiving, well, you can look on the reference guide, or there are APIs helper that from the number are telling you the strings of the error. And as I said, we have a guide, and we are working to improve the guide, also providing the what you should do when you get a particular error. In some cases, it's retry, like for a Google server unavailable. Sometimes the errors are very long. In this case, you can only retry. There is some problem on the backend, on the Google server side. And also in Play, there is a link available to see the status of the Google servers that you can check if you are getting more of these errors. Play Store not found. In some cases, you can have an old version of Play Store on the device, or can be a device in a strange status without Google Play enabled, or in some cases with some permission disabled for Play, and Play is not able to check the verdict to provide the information. Oops. And then there is this interesting error, the client transient error. It's transient. So it's a funny error in the sense that we are working to have a better classification for this class of errors. But at this moment, this is what you get. When you get this error, the guidelines at this moment is to retry. How many times you retry? We suggest to retry 3 times. After 3 times, you can consider that, okay, there is some problems, it's not going to solve it. Using an incremental backoff, what does it mean? The first retry is maybe after 5 seconds, then it's getting the same error. After 10 seconds, getting the same error. After 20 seconds, and then it's okay. I give up. It's not perfect, but it's also, in some cases, it's maybe a network error. So there is no way to bypass that. I said that this API is the evolution of the SafetyNet attestation. In reality, it's way more than SafetyNet attestation because SafetyNet attestation was giving you a verdict about the device integrity. But if you are using SafetyNet attestation, you have a migration path to the Play Integrity API. So yeah, but I'm okay with the SafetyNet attestation API. Yes, but it's deprecated. Well, it was out of beta since a long time, so you should have expected it. So this is the timeline. And by the way, we are here. So we announced more than 1 year ago deprecation. There is now a deprecation information field when you use the SafetyNet Attestation API. You get this additional field that tells you the API is deprecated. From January of this year, we don't onboard new developers on the SafetyNet API. And you need to migrate. There is a deadline. So this was in June 2023, has been extended to January 2024. What does it mean, this deadline? It means that you need to have integrated in your application the Play Integrity API. Obviously, if you release a new version of your application with the Play Integrity API, not all the users will get the latest version. So once you integrate the API, you get a waiver to keep using the SafetyNet attestation for another year. It means that if you have not migrated by January 2024, SafetyNet attestation stops to work on your application. If you start to migrate, there is a version of your application using the Play Integrity API, you get an additional year because we understand that not all the user gets the last version of the application. But if you never migrate, they will never be able to get the Play Integrity API. Okay, next step. We have a code lab. And it's a work in progress in the sense that the code lab for this API, it's huge because so it's covering, there is a backend, there is the native application, there is a Kotlin application, there is a Unity project. It's currently covering only the classic request. So we are rolling out the updates for standard, adding the support for standard request. I suggest that you take a look at it. And if you have questions, well, I'm here for a couple of days. And other things is that you can ping me on Mastodon. And thank you.
Thank you, Pietro.